The topic of today's video will be linear fractional transformation, and this is the most general cases of all the transformation we have studied so far. It means that the linear transformation, that is Tz equal to Az plus b, and that inversion transformation or reciprocal mapping, Wz equal to 1 over z, all of them are components of this linear fractional transformation, and that's why this is the most general transformation, right? In this video you will also see that how this linear transformation maps circles to straight lines or straight lines to circles, right? So I will start with the definition of this linear fractional transformation. Suppose A, B, C, D are complex numbers such that AD minus BC is not equal to 0, right? Then WZ equal to AZ plus B over CZ plus D is called linear fractional transformation, or you say it Mobius transformation, right? Or you have another name for it also, that is called bilinear mapping, right? So a mapping of this nature, Az plus b divided by Cz plus d, where AD minus BC is not equal to 0, is called linear fractional transformation, and that is also called Mobius or bilinear transformation, right? You can see that the numerator, that is Az plus b, is essentially the same as linear mapping Az plus b, and you can see that z is present in the denominator, and that indicates that it is containing that reciprocal mapping, that is 1 over z also, right? Okay, so what happens if we choose C equal to 0, right? So put C is equal to 0 here, you will be getting Wz equal to AD over Z plus B over D, right? And that is of the nature AZ plus capital B. I have replaced this A by D by capital A small b by small d by capital D, and this becomes a linear transformation, is a linear transformation, right? Okay, and we want to investigate that this transformation is conformal or not. Recall that mapping is said to be conformal at the points where its derivative become non-zero, right? So I will find its derivative and will investigate whether it becomes 0 or not, right? Since W dash Z, I will differentiate it, and that will produce Cz plus D whole square, Cz plus D, and multiplied by A, I think minus Az plus B and multiplied by C, right? So we will be left with AD minus BC in the numerator, AD minus BC over Cz plus D whole square, right? And this is not equal to 0. Since you read this hypothesis, this AD minus BC should not be equal to 0. So it is not equal to 0 as AD minus BC is not equal to 0, right? Okay, so we can say that therefore Wz is conformal in its domain, right? And domain with z is not equal to minus t over c, right? You have to remember this point, that if you put z equal to minus d by c, then you are getting 0 in the denominator, and you should avoid that point, right? So we are writing that this function is conformal at all points where the denominator is non-zero and we have to exclude the poles from it, right? Poles are singularities, and at singularities a function cannot be conformal. That's why you have to avoid all the singular points also, right? So this is called linear fractional transformation, right? And since in the last video we have introduced a new concept of z equal to infinity, that's called the ideal point of extended complex plane. So I will rewrite this definition in case of extended complex plane. Recall that in extended complex plane we allow ourselves to use that point z equal to infinity, right? So I will rewrite this definition in extended complex plane. In extended complex plane, and extended complex plane we mean that complex plane adjoined with the infinity, right? This Tz, this Wz, sorry, Wz is defined as Az plus B over Cz plus D, and this is valid for D is not equal to minus D by C, that is not equal to minus D by C, right? And okay, and yeah, Z is not equal to infinity, right? So this transformation is the same, and this was actually defined for a complex plane, but since we have extended this definition for the extended complex plane, so I will write two more points here. What happens when Z equal to infinity, right? And what happens when Z equal to minus D by C, right? Okay. So when we put Z equal to infinity, if you put Z equal to infinity here, you will get infinity over infinity form, and you have to apply then L'Hospital's rule, and you will differentiate the numerator and denominator, you will get A by C, right? So the answer is A by C. And what happens if you put Z equal to minus D by C in the denominator, right? So then you will get infinity, right? So I am writing infinity here because I am working on extended complex plane, right? Otherwise we should have written not defined, right? So this is the linear fractional transformation, right? And now I will take examples of it. Example number 1, find the image of mod z equal to 2 under the linear fractional transformation defined as Wz equal to z plus 2 over z minus 1, right? So you can see that this is a linear fractional transformation, and you should check that condition AD minus BC is not equal to 0, right? So you just pick up the A, B and CD, A, B, C, D. So AD will be minus 1 and BC will be 2. So ultimately AD minus BC is equal to minus 3, I think, and that is not equal to 0. So this is a linear fractional transformation. Okay, now we will see that what is the image of this. This is actually a circle. Mod z equal to 2 is a circle centered at origin and radius equal to 2. Okay, and under this mapping what will be its image, right? And I will add one more point. Also find the image of interior of this circle, right? Okay, solution. Here W is equal to z plus 2 over z minus 2, that is given to you, right? The first thing is that you should express this as a function of W, means you have to evaluate z from here as a function of W, right? So I will cross multiply it, or then I will get Wz minus W equal to z plus 2, and this will give you, I think it will be taken here, z equal to W plus 2 and W, I think minus 1, W minus 1, yeah, W minus 1. So ultimately you have expressed z in terms of W. That is the first thing you have to do. And now since your domain is this mod z equal to 2, right? Since domain, or you should call it, yeah, domain is not equal to, I am not writing that, I will draw that figure. Mod z equal to 2 is the circle centered at origin and radius equal to 2. This is your mod z equal to 2. This is your xy plane, x and y, z plane, right? Okay. And since mod z equal to 1, this will implies that z has value mod of w by 2 over w minus 1 equal to 1, right? And then you know that the modulus of a fraction is equal to the ratio of their modulus, right? Okay, and then you will cross multiply it. You will get mod of w plus 2 equal to modulus of w minus 1. And since you know that w is actually your w plane, in which you have u axis and v axis perpendicular to each other, so w is actually u plus iota v, right? U plus iota v plus 2, and here you will have u plus iota v minus 1, right? And then you will take the modulus of this thing, right? And the modulus will be u plus 2 square plus v square square root, right, equal to u minus 1 whole square plus v square square root, right? And on squaring both sides, you will get on squaring and simplifying also, you will get u square plus v square. I think that will be cancelled. U square plus v square will be cancelled on both sides. From here you will get 4 plus 4u, and from this side you will get 1 minus 2u, yeah, 2u, right? Okay. Sorry, it was mod z equal to 2. 2. So here we'll have 2, right? And on squaring we'll get 4 times of this thing, right? Okay. Oh no. We will be getting u square plus 4 plus 2u plus v square, and from this side on squaring we get 4 times u square plus 1, it means 4 minus 2u minus 4u plus 4v square. Okay, right? Ultimately we will get 3u square plus 3v square, right? And okay, these terms minus 6u, and then 4 will be cancelled out, equal to 0, right? So on dividing it by 3, you will get u square plus v square minus 2u equal to 0. And you can see that this is a circle, right? Circle centered at 1, 0, and radius is equal to 1, right? The circle has a standard equation, u square plus v square minus 2gu, sorry, plus 2gu plus 2fv plus k equal to 0, right? So the centers are given by minus half the coefficient of u, comma, minus half the coefficient of v, and since the coefficient of u is negative of 2, so minus half multiplied by minus 2 will be equal to 1, 0, right? I will write that is a circle, is a circle centered at, the center is half, 0, and radius is 1, sorry, 1 by 1, 0. Okay, so I will draw that image with my red marker. Here is the image. This is your u axis, this is your v axis, right? So you can see that the center is at 1, 0. Okay, it was 2, so it is 1, 0 is the center, and radius is equal to 1. Okay, so it will passing through 0, 0 like this. Right, center is 1, 0, and radius is equal to 1, right? Okay, so going to the next part, find the image of the interior of the circle, right? It means that the interior of this circle is this shaded region, right? You have to find its image, the image of the shaded region, right? And for this you just need a test point. You just take a test point which belongs to this shaded region. You can take any point. Suppose you take z equal to 0. This is a test point, right? Test point z equal to 0, and you just put this z equal to 0 here. You will get minus 2, right? I will write that here. Take test point z equal to 0 belonging to your domain n domain, right, and not the boundary point. Remember that, because this boundary has been mapped to the boundary, right? So you have to take a test point belonging to the inside of this boundary, right? So that is z equal to 0 is a good point in the domain. Then w of 0, if you plug 0 here, you will get -2, right? So this test point belonging to the inside of this circle is actually mapped to the outside of the image circle. Where is -2? -2 should be here, I think, here, right? Outside, right? That is outside of mod. What is that circle? That circle was centered at 1. Okay, fine. W minus 1 equal to radius was 1, right? Outside of W minus 1 equal to 1, and that's why I will shade the outer region. You have to shade the whole region that is lying outside this circle, right? All of the region, right? Okay. So in summary, you can say that this disk, if you consider this region together with this boundary, it means that mod z less than or equal to 2, right? The closed disk, the interior of disk, that is mapped to the exterior of this disk, right? So I will write that point in general, or you can say in summary, mod z less than or equal to 2 is mapped onto mod w minus 1 greater than or equal to 1. The interior of the disk is mapped to the exterior of the disk, right? So this is the picture, and this was your test point. This was the image of test point that is denoted by w0, and that is equal to how much? -2, right? Okay, I will take another example. Example number 2. Find the image of wz equal to image of mod z equal to 1 under wz equal to z plus 2 over z minus 1, right? I have changed the circle only, the mapping is same, right? Also find the image of interior of your disk, right? Okay, so proceeding in the same way, solution, since that is given, w is given to you, w is equal to z plus 2 over z minus 1, and on cross multiplying and simplifying, that will give you gives you z equal to w plus 2 over w minus 1, right? And again, this time the domain is a unit circle. I will draw that. This is a unit circle centered at z equal to 0 and radius equal to 1, right? So z equal to 1. This is the x-axis, this is the y-axis, this is your z plane, right? This is the w plane. Okay, so since mod z equal to 1, this time we have mod z equal to 1, that will give me mod w plus 2 over w minus 2 equal to 1, and on cross multiplying and simplifying, you will get I think I should see from there, I will get something like this: u plus eta v plus 2 mod equal to u plus eta v minus 2, and on taking modulus of these both sides and squaring both sides, I will get, after squaring, that should be u plus 2 whole square, right? U plus 2 whole square plus v square, and here I will have u minus 2 whole square plus v square, right? On squaring both sides, and then v square will be cancelled out, u square will be cancelled out, we will have 4 will be cancelled out, yes, and from here we will have 4u here minus 4u, right? So 4u equal to minus 4u, right? And that will give me 8u equal to 0, right? And then u is equal to 0, right? And what is this u is equal to 0? U is equal to 0 is the v axis, right? So I have to draw that axis here. That is v equal to 0 is a perpendicular line, vertical line, a vertical line v axis, right? So I will draw that line with my red marker. This is your v axis, u axis, right? And the image is actually u is equal to 0, and u is equal to 0 is this axis. So I will draw that with my black marker, right? Okay. So this is the image, the circle, the boundary of the circle. It means the circle is mapped to this line, right? And now I will take a test point because I need the image of this thing also. And mod z less than or equal to 1 is the interior of this circle. So I will take just a test point. Let that point be z equal to 0, right? This is a test point z equal to 0, and you should plug z equal to 0 here. You will get w equal to -2, right? So where is -2? -2 is here. -2 will be here. Okay. W of 0 equal to -2. It indicates that this test point, which belongs to the interior of this disk, is mapped onto the left hand side part, right? It indicates that the whole left hand side part will be the image, right? You have to shade it. This is the image of interior of your circle, right? The left hand side part. Okay. This is W plane. So in all, I will write that the image of this will be the left hand side or the left half plane, right? Okay. Take test point z equal to 0 in mod z less than or equal to 1 to get w0 equal to -2, and that belongs to the left half portion, right? Therefore mod z less than or equal to 1 is mapped onto the left hand side portion, and you should write it as, for this portion, v is negative, no, u is negative, right? U is lesser than or equal to 0, because you have to keep this u equal to 0. U is equal to 0 when z equal to 1, mod z equal to 1, right? And for mod z less than 1, u less than 0. So in all, you have to write this, right? It has two components actually. U equal to 0 for the image of this boundary, and u less than 0 for the image of this shaded region, right? So this is the final answer. Okay. So in two examples, you can see that the mappings were same, right? But the circles were different, domain was different. Here in this case mod z equal to 2, and here the circle was mapped to a circle, right? But here the circle was mapped to a line, and that's the amazing thing this linear fractional transformation can do with circles. It can map a circle to a circle like in first example, and it can map a circle to a line as in second example. But the point is that how can we identify that when a circle is going to map to a circle or a line, and that fact is supported by a small point. If you see this here, or you see here, you can see that the pole of this function is at z equal to 1, right? So z equal to 1 is the pole of this function, and that pole was lying actually on the boundary of this circle. You can see that z equal to 1 is this point, z equal to 1. This point is z equal to 1, which was a pole, right? And that's why the circle was mapped to a line, right? And in this mapping, the pole was z equal to 1, but that was not lying on the circumference, that was lying inside the circle, right? So you can say that if you have a pole which lie on the boundary of the circle, then the image is always a straight line, right? Otherwise the circle is mapped to a circle. Okay. So taking my next question. Example number 3, find the image of the figure shown under Wz equal to z over z minus 2, right? And the figure is like this. This is the figure. You have this semicircle belonging to the upper half plane only, and this is the x-axis, this is the y-axis, and this is the shaded region, right, outside of this semicircle, right? Okay, and suppose it is of radius 2, right? So you need to find the image of this shaded portion, and this region is comprising of this circumference and this together with this upper half plane, right? Okay, first you have to express it in mathematical form because this is a figure. So I need to write the equation of this thing, shaded region. Solution. Okay, solution. Now first your domain is yeah, it is a part of circle. I should write mod z equal to 2 because the circle is centered at origin and radius equal to 2. So the first thing is that, and since it belongs to the upper half portion, and for the upper half portion we have y positive, right? So I will write that with y greater than or equal to 0. Should I put equal to here, y equal to 0? Yes, y equal to 0 is also included. You can see that this axis is also included in your domain. So you have to put equal to here, right? So domain is this thing, right? Okay. Now I will find the image under this transformation, right? You need to write your domain in this fashion. Mod z equal to 2 for the circle and y greater than equal to 0 for the upper part of the circle, and y this equal to for this axis also, right? Okay. Now cross multiplying it, you will get w equal to z over z minus 2 will give you, I think that will give you wz, and then minus 1, that will give you z equal to wz minus 1. So w minus 1 will be in the denominator, right, and minus 2w, that will appear on the right hand side, 2w, right? Okay, then I think I should use this, right? First I will use this, then I will consider this, then mod z equal to 2, right, implies, if you plug the value of mod z, 2w over w minus 1 equal to 2, and cross multiplying, I think this 2 and 2 can be cancelled also, right? And on cross multiplying it will give you mod w equal to mod of w minus 1, right? And then you will put that u plus iota v in place of w, and you will get u square plus v square on squaring it, and u minus 1 whole square plus v square, and then I think u square plus v square will be cancelled out, and from here you will be obtaining 1 plus I think 0 equal to minus 2u plus 1, and yeah, ultimately that will be equal to u equal to 1 over half, and that is a straight line. Again, u is equal to, there is a vertical line, right, which is a vertical line, right? And I should draw that v axis, u axis, this is a w plane, right, and this is your u is equal to half, there is this vertical line, u is equal to half, right, and y greater than or equal to 0, and you know that y can be written as z minus z bar over twice of iota, right? And cross multiplying it, you will get z minus z bar is greater than or equal to 0. But now what do I need? I need the values of z and z bar. From here I will plug those values here, right, and that will give me, implies value of z is this thing, twice of w over w minus 1 minus twice of w bar over w bar minus 1, right? Okay, and that is should be greater than or equal to 0, and on simplifying it I will be having I think twice will go, okay, and you will be having w bar minus w bar w plus w bar greater than or equal to 0, and this will be cancelled, and I will be left with w minus w bar. This inequality will be reversed as I have changed these signs, and on plugging the values of w is actually u plus eta v, and this is your u minus eta v, right? It will produce twice of eta v less than or equal to 0, or you can say v is less than or equal to 0, right? And if you say that v is less than or equal to 0, it means that v, this is your v equal to 0 is on u axis, and v is negative for the lower half portion, right? That is the lower half plane, that is lower half plane, right? And now I will shade the lower half portion only, right? I will take that test point inside this shaded region and let that point be 3. Take z equal to 3, right? That will give you w3 equal to 3, and on plotting this w3 equal to 3, I will get a point here. 3 will be here because this is u is equal to half, right? So u equal to 3 will be here, right? It implies that this shaded region will be mapped onto this portion, right? This portion. And why this portion? Because from here you are getting that v is less than or equal to 0, or it is obvious that v is less than or equal to 0 is for the lower half plane, right? So a possibility is also there to shade that you will shade this part also, but if you take the test point, it clearly indicates that the right hand side of this line should be shaded, and that is a very important point, right? Because from here you are getting that v is less than or equal to 0, it indicates that the lower half plane should be shaded, right? But if you take a test point here, z equal to 3, you are getting w3 equal to 3, and that is on the right half of this line. So ultimately the final image will be the right half of this vertical line, right? Okay. Therefore therefore I should write it as therefore the image is the right half of u equal to 1 by 2 and v is less than or equal to 0, right? So this is the complete answer. Okay, and I will take one more example to see what happens with the line. As we have seen in example number 1 and 2, that circle is mapped to a circle, or a circle is mapped to a line when the pole lie on the boundary of that circle, right? So I will take, this time I will take the domain as a line, and we'll see what happens. Example number 4, find the image of a line, and that line is x equal to 1, right? Under wz equal to z minus 1 over z plus 1, right? This time you are given a line and you have to find its image, right? Let us see what happens whether a line is mapped to a line or a line is mapped to a circle, right? Solution, you can write it as, since w equal to z minus 1 over z plus 1, that will gives z equal to, I think, wz minus z, that will produce w minus 1 in the denominator, and w, and this is minus 1, so I think minus 1 minus w, if I'm not wrong. Yeah, wz minus z, that is w minus 1, w is, okay, minus 1 minus w, right? And okay, now this is x equal to 1, and this is a line. Now line is x equal to 1, or you can write it in this form, z equal to x plus eta y, x is equal to 1, so 1 plus eta y, and y will vary from minus infinity to infinity. So this is the equation of a line in complex plane. Okay, Then I will put this value here, that will give me then z equal to -1 minus w, right? Okay, I should I should not find the value of this z, right? I should substitute this z equal to 1 plus iota y here. Okay, that will give you w equal to z 1 plus iota y, so it will be iota y only, and z plus 1, that will be 2 plus iota y, right? And now I will rationalize it, or w equal to, if you rationalize it with 2 minus iota y, you will be getting 4 plus, or y square plus 4 in the denominator, and 2 minus iota y multiplied with this will give you 2 minus iota y, that will give you 2 iota y, and 2 minus iota y, I think y square, right? Okay, and on writing it as u plus iota v equal to y square over y square plus 4 minus twice of iota y over y square plus 4, right? And now I will equate the real and imaginary parts. Okay, equating real and imaginary parts, you will get u is equal to y square over y square plus 4, and v equal to minus of 2y over y square plus 4. Now I need a relationship between u and v, and for that I have to divide them. I will get divide u over v is equal to, I think, minus y over 2, right? Or that will give you y is equal to minus of 2u over v, and putting this value here in equation number 1, put y equal to minus 2u over v in equation number 1, you will get, I will put here, u equal to y square will be 4u square over v square, and 4u square over v square plus 4, and on taking LCM I will get to, I think, v square will be cancelled, u square over u square plus 1, right? And on cross multiplying it, I will get to u square minus u, I think this will be v square, sorry, v square, so u square plus v square minus u equal to 0. And you can see that this is the equation of a circle, is a circle centered at, the center is minus half the coefficient of, that will be 1 by 2 comma 0, and radius equal to 1 by 2, right? So I will draw that circle, image circle. So this is your u axis, this is your v axis, right? And I have not drawn that line. That line was x axis, y axis. This is a line x equal to 1, right? And this is z plane, and this is a w plane, and this is a circle centered at half comma 0. So half comma 0 will be here, right? And radius is half, so it will be touching your y axis, right? So this is the image, right? Okay, so this is a center half comma 0, and radius equal to 1 comma 0, radius equal to half also, sorry, half comma 0. This is your image. You can see that this time the line has been mapped to a circle. So now comes the question, when a line is mapped to a line and when a line is mapped to a circle, right? So a line is mapped to a circle if you can see that pole of this function is z equal to -1, and that was not lying on this line, right? So whenever the pole of the function is not lying on the line, then you will always get a circle, right? And whenever the pole of a function is lying on the line, you will get a line, right? So in all, we can say that a line is mapped to a line whenever a pole of the function is lying on the line, right? And a line is mapped to a circle whenever the pole is not lying on the line, right? And the case with the circle is different. Circle is mapped to a circle whenever there are no poles which lie on the boundary of the circle, and whenever a pole lie on the boundary of the circle, a circle is mapped to a line, right? So you have to remember these facts, and that are the amazing facts supported by this linear fractional transformation. This is it for this video. Thanks.